So with counting principles, I'm not too concerned about some of the stuff that happens here. The ones I'm mainly concerned about are permutation, which we didn't talk about yesterday. Permutation, the one thing we need to pay attention to is order matters. And then you can do the formula, which is n p r equals n factorial over n minus r factorial. So similar to yesterday, basically, if you're given a word problem where you have to go through and like a phone number where you can go through and the digits don't matter which order they're in. Oh, I guess it matters. Sorry, it matters which order they're in, like sequential order. Then you talk about permutations, but combinations you're going to talk about where order doesn't matter. So maybe like scoops of ice cream, you don't care what order it's in. So combination. Which we talked about yesterday. Order does not matter. And then this goes back to the same idea and the same formula as yesterday, which is our NCR and then equals n factorial over n minus r factorial r factorial. All right, so if you're good with yesterday's lesson, today's lesson is not going to be too terribly different or even too terribly difficult compared to that. We just set up things in terms of word problems, but when we talk about permutations, it's the same setup as yesterday for our basic ones, where we have the example of find 8p3. Well, if I work that out, it's as simple as going, well, hey, that's going to be 8 factorial over 8 minus 3, which is 5 factorial. And then if I think about that, that's going to be 8 times 7 times 6, because anything after 5 is going to cancel out because of the denominator. So you just multiply that out. 8 times 42. 336. I don't know. If someone wants to check that, please feel free to do so. But the math portion of that isn't going to be much different. Like, you're just distinguishing what pieces that you need from that. Are we okay with that?
So, like, okay, are you not multiplying the r factorial in that one?
No, because for permutation, you just do the n minus r. It's slightly different.
That wasn't C, John. That was P.
Yeah.
On the
Okay.
So
Yeah,
combinations, you're multiplying by the r in the denominator. Permutations, you're not.
Okay.
Okay. So moving on. Let's talk about a word problem. Because it's Wednesday. And in case you didn't know, that means Word Problem Wednesday. All right. Glad we had that conversation. So
I just thought you were talking to yourself.
Sometimes. So a standard poker hand consists of 5 cards. Dealt from a deck of 52. If you did not know there is 52 cards in a deck, now you know, because we'll be talking about probability, and I always relate it to a deck of cards. If you didn't have to play 52 card pickup as a child, then you probably had a good childhood.
I had a good childhood.
How many different
Yeah, Jamie, let's quiet it down.
poker hands are possible?
10.
All right. So the thing is, if they say how many different poker hands are possible, they didn't give you a limit of they have to be in a certain order, right? So this means it's going to be a combination. So due to this statement, where they don't give you order, then you know it's combination. Now, you have to think about your hand consists of 5 cards, and there's 52 cards in total, right? So really you're doing something like 52 cards in total for the combination of 5. Does that make sense to everybody?
Yeah.
All right. So you do 52 factorial over, then you have your 52 minus 5 factorial times 5 factorial. So you have 52 factorial over 47 factorial times 5 factorial, which really means you have 52 times 51 times 50 times 49 times 48 all over 5 factorial. All right, so you'd have to work that out in a calculator. That number ends up being 2,598,960. All right, so even the word problems, in my opinion, aren't too bad. Like, you just have to pick out the information and plug it in. And it doesn't really change much from that. Like, permutation would work the same way. So nothing too crazy for that. That is combinations and permutations.